Good day to our beloved students. Welcome to our math class. It's a great pleasure for me to teach you and give you the learnings needed for our today's lesson. Our objective is to solve problems involving angles of elevation. Are you ready to further understand the lesson? Okay, let's begin. Our lesson is all about solving problems involving angles of elevation. In this video, we will use the knowledge and skills that we have learned in our past lesson to solve real-life problems involving angles of elevation. Knowing and familiarizing with the use of trigonometric ratios will help a lot in solving problems involving angles of elevation. In our previous lessons, we have already learned about the 6 trigonometric ratios and the angles of elevation and depression. For us to recall our past lessons, let's first fill the blanks with the missing term or terms for each statement. For number 1, blank is an imaginary line that connects the eye of an observer to the object being observed. If your answer is line of sight, then you got the correct answer. For number 2, the angle of blank is the angle formed from the horizontal line of sight of the observer to the object above. Can you guess the correct answer? If your answer is elevation, very good, you are correct. For number 3, blank are the ratios of two sides of any right triangle. Have you figured out the answer? If your answer is trigonometric ratio, well done, you got the correct answer. Let's proceed to number 4. In angle of elevation, the object being observed is blank, the observer. What do you think will be the answer? If your answer is above, you got the correct answer. And for the last number, blank is the trigonometric ratio of two legs of a right triangle. If your answer is tangent ratio, well done. Your answer is correct. Since we already learned and recall our previous lesson, we are now ready to move forward and discuss our lesson for today, and that is solving problems involving angles of elevation. Let us analyze carefully the given illustration below to answer the following questions. In our illustration, a boy is standing 60 meters away from the tree, and from the point where the boy stands to the top of the tree, the angle of elevation is 42 degrees. Can we name the angle of elevation in the given illustration? Yes, the angle of elevation is angle HPT, and angle HPT is equals to 42 degrees. Next, what segment shows the line of sight in the given illustration? The line of sight from the point where the boy stands to the top of the tree is segment HP. For our third question, what trigonometric ratio can we use to find the height of the tree in the given illustration? As you will notice, the distance of the boy from the tree is adjacent side of the right triangle, and the height of the tree is the opposite side of the angle of elevation. Since the opposite side and adjacent side are part of the problem, therefore, we can use tangent ratio to solve for the height of the tree. Here are some suggested steps in solving problems involving angles of elevation. First, we must draw a triangle to fit the problem. Then, label sides from the angle's view. After that, we identify the trigonometric function to be used. Then, we can now set up an equation using the given in a trigonometric function that we will use. After we set up the equation, we can now solve for the variable. If the missing value is the measure of the angle, we use the inverse trigonometric ratio to determine its measure. Take note, a trigonometric ratio often helps us to set an equation which then we solve for the missing measurement if two legs of a triangle are part of the problem. Then it's a tangent ratio. And if the hypotenuse is the part of the problem, then it's either a sine or a cosine ratio. Now let us have an example. A tower is 15.24 meter high. At a certain distance away from the tower, an observer determines that the angle of elevation to the top of the tower is 41 degrees. How far is the observer from the base of the tower? To be able to answer the given problem, let us first determine what sides of the triangle shown in the picture is part of the problem. As you can see, the sides that were part of the problem are the opposite side and the adjacent side. Therefore, we use tangent ratio to solve the given problem. Remember that in tangent ratio, the opposite side is divided by the adjacent side. Then, let us set up an equation by substituting the unknown to the equation. Substituting, we have tangent 41 degrees is equals to 15.24 divided by x. Then, we multiply both sides of the equation by x and the reciprocal of tangent 41 degrees to isolate the variable on one side of the equation. Thus, we have x is equals to 15.24 divided by tangent 41 degrees. Solving for the value of x, we have 17.53 meters. Therefore, the distance of the observer to the base of the tower is 17.53 meters or 18 meters. Let's have another example. A 4-meter ladder leans against a wall. If the foot of the ladder makes an angle of 80 degrees with the ground, how high up the wall does the ladder reach? To solve the given problem, let us determine what sides of the right triangle are part of the problem. The opposite side and the hypotenuse of the right triangle are part of the problem. Thus, we use sine ratio to solve the problem. Remember that sine is equal to opposite side divided by the hypotenuse. Then, let's set up the equation by substituting the unknown and the given to the equation. Doing so, we have sine 80 degrees is equal to h divided by 4. Then, multiply both sides of the equation by 4 to isolate the unknown on one side of the equation. Thus, we have 4 times sine 80 degrees is equals to h. Solving for the value of h, we have 3.94 meters. Therefore, the height of the wall that the ladder reached is 3.94 meters, or simply 4 meters. For our last example, if an 80-feet flagpole casts a shadow of 46 feet long, what is the angle of elevation of the sun from the tip of the shadow? Let us first determine the sides of the right triangle that are part of the problem. As you can see, the opposite side and adjacent side of the right triangle are already given in the problem. Thus, we use tangent ratio to solve the problem. Tangent ratio is equals to opposite side divided by the adjacent side. Setting up the equation using the given on the problem, we have tangent theta is equals to 80 divided by 46. Since the unknown is the measure of the angle of elevation, we use the inverse trigonometric ratio of tangent, which is arctangent, to the quotient of 80 divided by 46. Thus we have angle theta is equals to 60 degrees. Therefore, the angle of elevation of the sun from the tip of the shadow is 60 degrees. So those are the examples on how to solve problems involving angles of elevation. To sum up our lesson, remember that to solve problems involving angles of elevation, these are the following steps. First, draw the triangle to fit the problem. Then, label the sides from angles view. Third, identify the trigonometric function to be used. Then, set up the equation. Finally, solve for the variable. Also remember that a trigonometric ratio helps us set up an equation, which then be solved for the missing measurement. So that ends our lesson in solving problems involving angles of elevation. I hope that you enjoy and understand the lesson that we have discussed clearly. If not, you may go back to the lesson presented. If the lesson is clear to you, congratulations! You may now proceed in answering the exercises given to you in your module. Again, this is Mr. Herbert Evangelista, your math teacher, saying good luck, stay safe, God bless, and enjoy learning. See ya!